Well, we've finished the first step of our journey. We've talked about the platform Node.js. Let's move our way up the NEMA stack and focus on Express.js now, our web server. Now, Express.js, if you go to expressjs.com, you'll see that Express is a fast, unopinionated, minimalist web framework for Node.js. But before we get into Express, I want to focus on Node because one common misperception is that Node is a web server. Now, we've already discussed that Node isn't a web server, it's a platform based on Chrome's JavaScript runtime. What I want to focus on now is actually the second sentence on there, that Node.js uses an event-driven, non-blocking I/O model. And we'll get a chance to see a lot of different examples of this in action, but this is where I think the misconceptions begins. When we go to Node.js and their hello world example is in fact a web server, I don't blame you for being confused. But what they're trying to demonstrate to you is that this is a platform that has HTTP capabilities baked into it. You're able to require in that HTTP library. I'm going to expand this code out where we'll see this in action, but let's explore this since it's up in front of us right now. We'll see that once I've brought in the HTTP library, I can create a server. And that function that you see inside of the create server is in fact an anonymous event handler. You're getting passed in a request, you're getting passed in a response, and we can see every request that comes in. They're writing out a basic header, a content type of text plain, and they're saying hello world. And in fact, we're listening on port 1337, the LEET port, and we're listening on localhost. But while it's cool that we can get a web server up and running in half a dozen lines of code, this is a very compact bit of code. And so what I'd like to do is expand on that idea a little bit and really draw your focus to two important concepts. We're going to see how modules come to play, and we're going to see how very asynchronous JavaScript is. Because whereas Java is not just a little bit object-oriented, its classes all the way down, you're going to find that JavaScript is not just a little bit asynchronous. It's asynchronous all the way down. So let's expand out this example, this simple hello world, we got a web server up and running in half a dozen lines of code, and look at something that's going to be a little bit closer to what you'll see in production. At the top of our file, you see we're using useScript. That magic string useScript is an ECMAScript 5 string. And really what it says is turn off much of the madness of JavaScript. Turn off global variables. Turn off using variables that haven't been defined yet. Do a lot of good things. So useStrict is a magic string that ECMAScript 3 platforms will ignore, but ES5 and beyond will pay attention, and it'll add extra rigor to your code. But once we've put that magic string in place, you can see what we're doing is we're bringing in libraries. We're bringing in HTTP. We might bring in the URL library that helps us manage query strings. But you're going to bring in a number of different modules. You're also going to set up some dependencies. And rather than having them hard-coded like we saw in the previous example, in this example here, what you'll see is we're bringing them in based on environment variables. This is a very common pattern where if I set a port variable to 9999, we'll try to read this in or, the double pipe being or we'll use this default value. Now, of course, you don't have to use an environment variable. You could read them in from a config file. You can do any number of things. But this is a way we can start bringing in our variables. You notice we're declaring all of our variables up at the top of the file because JavaScript does something called variable hoisting, which no matter where you use those variables, they're always defined up top. So as we define all our variables up top, the next thing we do is we start breaking out our request handlers. Because if we go back and look at this code for a moment, there's nothing wrong with this code. There are no bugs in this code, but it's not very testable. How do I get at that anonymous request handler? Well, I have to spin up a server and send an HTTP GET request to port 1337 on this IP address. In order to make this a little bit more testable and arguably more readable as well, we will pull that request handler out into a separate function that can be separately unit tested. We'll also find that this startup handler is solving a more subtle bug that we didn't notice the first time around. If you're like me, I've been dipped in synchronous programming from a tender young age. As I'm looking at that and looking specifically at the console log, there's a very subtle bug lurking to bite you. Now, this is a fairly benign bug, but the bug that we're talking about is that web server isn't necessarily up and running when you say the web server is up and running. Now, again, that's not a showstopper bug, but what we'll find is that listen method is just as asynchronous and event-driven as the create server method is. So if we use a slightly more advanced version of this, we will also have a startup event listener that will come up and make sure that the server is up and running before we display what port and address it's using. So we've defined our event handlers up front, and at the very bottom of the screen, you'll see that server equals that create server, and we pass in the tested request handler. And then when we ask the server to listen, we pass in the port and the host name, and we pass in our well-tested event listener as well. JavaScript's not just a little bit event-oriented. It's event-oriented and asynchronous all the way down. So trying to compare Node to browser, you're going to see a lot of similarities. Certainly in the browser, you use a script source to bring in your third-party libraries. In Node, you're going to use a var express equals require express. We'll talk more about this, but the difference here is that Node uses something called CommonJS modules. And what's really important about what you see on the right-hand side of your screen is that when you bring in express, it's namespaced. So you could bring in both Express 3.0 and 4.0 by assigning them to different namespaced variables. You also, as you're bringing in Express, are bringing in all of Express's transitive dependencies. And once you start playing in that realm, you're never going to want to manually deal with your dependencies by reordering the script sources to make sure that you bring in the lower level dependencies before you bring in your higher level libraries. That's something much better managed by computers than humans with very tiny brains. But once we get these libraries in place, you'll see that the events are handled almost identically. Client-side events look exactly the same as server-side events. The only difference is what events are getting generated. On the client side, you're going to be listening on events like timeouts, or user events like on mouse over, on mouse down, on mouse move, on mouse up, on click, on double click. The type of events you're going to see on the server are going to be things like once the server is up and running, once the request comes in. These are the kinds of events you're going to listen for, but you're going to see that the boilerplate, the way you deal with these events, is identical across platforms. So hopefully we've established that Node is not the web server. Despite their best efforts to confuse you, Node.js is a platform that allows you to bring in libraries to make Node a web server. But you can also have lower level libraries like Net to listen for TCP packets and UDP to listen for stateless packets, UDP packets. You can also bring in higher level protocols like Socket.io that will bring in WebSocket support. You can bring in SMTP servers. You can bring in FTP servers. And we'll talk about this in greater detail. But what this means is that you are bringing these services into your application rather than deploying your application to an external container where you do this configuration. Express.js is just one example of bringing these kinds of services into your application. So yes, Linux moves to Node as we're discussing the platform, but Apache moves to Express as we're talking about web servers. And in order to really solidify this idea in your mind, let's build some mental models of what we're looking at. When we look at the LAMP stack on the left, what you see there is our Linux, our Apache, our MySQL, our PHP, or Perl, or Python. But what that image on the left is demonstrating to you is that we in fact do deploy our application to the web server. What that means is if we're using a PHP application, we need to make sure that Apache is configured with mod PHP. It has the plugins available to it. If you're using Perl, you need to make sure it has mod CGI. If you're using Python, you need to make sure that Apache is configured to run that Python code for you. In the mean stack, you invert that relationship. Rather than deploying your application to a container, you bring that container into your application. This is why we bring in Express.js. And if you want to support WebSockets, you'll bring in Socket.io. If you want to support SMTP or FTP or Telnet or SSH or anything else, you will bring those libraries, those modules into your application. It's really no different than what you do in the browser. If you're writing a Backbone app, you need to bring Backbone into your application. If you're writing a jQuery app, you need to bring jQuery into your application. So in that sense, it's no different. The only difference is we're running on the server and bringing in server daemons rather than client-side libraries. But we're really essentially doing the same thing.